Bismillahirrahmanirrahim. This question, he said, by sketching suitable pairs of graph, so show these two equation of curves have a one root lie between 0 and pi. So let's see how we can do this kind of question. So I will break in two parts. First of all, y is equals to cosecant half x and y equals to 1 over 3x plus 1. So this separate and this separate, I will make it. And how to do it? And 0 to pi, he said. 0 to pi, and what I will do, students? So I will make a graph. Okay. And basically, what student criteria? Because power 1 here. Okay. So I make it 1 here and I make it 2 here onwards. Okay. So 0 to pi is actually, what is pi value, student? 3.14. Okay, so this, let's say 1 here, let's say 2 here, this is a 3, and 3.1 slightly ahead. So I can take pi is somewhere here. So when I plug in 1 in the place of x, or plug in 0, best idea is 0. When I plug in 0 in the place of x, I get a 1, which is here. So I'm getting 0, 1 here. And when I plug in, for example, 3 in the place of x, so let's see what happens. 3 will cancel there. So 1 over 3 into 3, cancel 1. 1 plus 1 give us 2. So 3 and 2, they meet here. So this point, I get it. And I'm going to make a line joining them. Okay. And I believe this point is also very, very clear. So this done. So wait a minute, please. So this is no need to show working. All right. Okay. So this is clear. So let's talk about the next part. Sorry, next onward, what will happen afterwards. So I will plug in 0 in the place of this. What is a cosecant, students? For your knowledge, cosecant is actually 1 over sine. 1 over sine half x. So when I plug in 0 in the place of x, 0. So sine 0, 0 is infinity. It means at 0 we have infinity, we can't sketch it. Okay, so this will leave it. And when I plug in, students, 1 in the place of x, so I will get what answer? Let me check it. Against 1, I am getting 2 point something, 2.1 something. So against 1, 2 point something. So graph I am having here. So against next number is 2. When I plug in 2 here, so what I get, student, I'm getting 1.18. So 1.18, 1.18 somewhere here. Against 3, when I plug in 3, okay, what I get answer, I got a sharp 1. So a sharp 1 means here. Not sharp 1, actually graph is going this way. Actually, we have a cosecant graph, it's like a U shape. Okay, I show you here, cosecant half x. Let's have a look here. So if I'll erase it and I go to show you a graphical cosecant x. You see, the student, we have many U shapes. We can see from here, many U shapes, but with this U shape, I have to make it so between 0 and pi. Okay, you can concentrate. This is a 3 and 3. This is a pi in value actually, and we have this part of graph. Okay, so it is very clear. All right. All right. Sorry, I did not make a half x. So there's a reason. So if I make it half x here, half x, 1 divided by 2, 1 divided by 2. So now you see the graph came in different format. So I think now you feel better. So this is a 3 point here. This is pi value, 3 point something. This part of graph I drew already. So I believe you got a point very clear. So let's talk about the this concept here. So this is clear. Now, students, I can complete it now. This is okay. And just write proved. Why proved? Because he was asking that it has a 1 root. It has a 1 intersection point, and that I got it. So let's talk about part number 2. Show by calculation the root lies between 1.4 and 1.6. We have two options, either bring this left side or bring this on the right side. Okay, I can bring any one side. So I'm writing here part number 2, f of x is equals to cosecant 1 over 2 x minus 1 over 3x and minus 1. So it is a very clear because I brought whole values left side. Now, students, what is the root lies between? He said 1.4 and 1.6. So one time I will plug in 1.4 and one time I'll plug in 1.6. So let's see what happens. But time, you can't type in calculator second. So must type sine. 1 over sine half times 2, 1.4 minus 1.3 into 1.4 minus 1. And then I will do the same process with a 1.6. So I copy the whole equation, copy and paste. So this, okay. And just a change, small change there. And that is here and here. And I will write 1.6 and 1.6. So, so what I check it, 1 over sine half times 2, 1.4, 1.4 and negative 1.4 divided by 3 and negative 1. I got answer, students, 0.085 positive. And now if I replace 1.4 by 1.6 everywhere, so what I get, student, I get answer in negative 0.13. So have seen, you can see here, as sign changes, write a statement here, as sign changes. So root lies between these numbers. So 1.4 and 1.6. So point is clear. Let's go for part number third. Part number third, he said, show that sequence of values in formula 0 to pi given by the iterative formula, this is converges to the converged root of the equation number 1. Repeat, converges means this equation will convert into this format, okay? So this word maybe sometimes confuses students. So gradually the answer of this converges to the root of this equation. How we can prove this connection? If I remove this subscript, I will remove first of all, okay? And then I will convert this equation to above equation. So let's see how we can do this kind of thing. So let's first of all, let me copy xn plus 1 equal to 2 sine inverse is a 3 over xn plus 3. So I copy this whole equation, cut from here, and part number third, I'm going to do here. So first of all, what to do? Remove, you will remove subscripts. So when I remove subscripts, remove. So I get x2 sine inverse over 3 over x plus 3. This 2 will go down and become a half x. And sine inverse of 3 over x plus 3. Sine will go on this side. Inverse will finish automatically. We get this kind of format. But you know, student, I said both sides, I must need single fraction. If I flip both sides, what will happen, students? So 3x plus 3 will go up and 3 will go down. And this become 1 over sine half x. And 1 by sine, you know, it's called cosecant. Cosecant half x equals to x plus 3 over 3. And this 3, and hold on, let me, yeah, this 3 divides both numbers. I mean, x by 3 separate. I got 1 by 3x. And 3 by 3 separate, I got a 1. And this is the same equation which we have here. You can see the same equation have here. Okay, so we can say hence proved. Just write proved. Okay, so this part is clear. Part number 4. What part number 4 student is asking for? Use iterative formula in a part number this 3 as 3 dp and give each answer 5 dp, but final answer 3 dp. So, but problem we are facing, do we have initial value given? No, initial is not given. So we'll take average of these numbers. So add them, divide by 2. So x1 equal to 1.4 plus 1.6 by 2. I got 1.5. So I think idea is very clear. So first of all, I copy paste here formula, and then you know we have a formula here already available. So wait a minute, this formula I'm copying. So copy and paste. Okay, and initial value you got at 1 minute, let me check, 1.5. 1.5. So student, first of all, I plug in every n by 1, every n by 1. So I get here 1 plus 1, 2, 2 sine inverse 3 over x1 plus 3. So this 1.5 will come here. So I've saved my time. I'm writing here 1.5 plus 3. And when I get value from here, just wait, students, I'm typing 2 times 2. Wait a minute, let me recheck again. Yeah, sine inverse. 2 times 2 sine inverse in fraction 3 over 1.5 plus 3. And 1.5 plus 3. And when I check in calculator, I'm getting here 1.45955 because he said 5 dp. So this is N1. Now go for N2. When I plug in 2 here and 2 here, I get x3 equals to 2 times 2 sine inverse. Okay, 3 over this whole value will come here. So I write 1.45955 plus 3 and it gives us x3. So let's see what I can get it. Hold on. I just plug in here my answer. I've got a 1.47578. Again, 5 dp. Now,
Sir,
yes, please.
sir, the x2 is 1.459455.
Let me check. 1.4594. Thank you very much. 94. This is a 94. Yeah, 945. Oh, 946 I can write. Thank you very much. So 946. And this answer is coming same with us. No change. Okay, now because I'm using my calculator, so that is why. So that is why I'm using the calculator answer technique I use. So the same value 1.47578 I use here and I get x4 and I'm getting answer what here? Let me check. Yeah, I'm getting 1.46916. Yeah, 916. We have to stop at 3 dp. Look at here, 3 dp is still not getting answers. Okay, so then when I get n x4, x5 is giving us what? 2 sine inverse 3 over 1.46916 plus 3. And when I get x5, I get my answer 1.47183. I think not 3, but I get 4. Okay. And then I go for, because still not matching, still not repeating, sorry. So 2 sine inverse 3 over, he said, show working of each iteration. We are bound. So anyway, x6 is coming 1.47075. Now see, student, this is start matching now. These are two values matching, and third, if I round it, it's becoming 2. Okay, I have to check one more because the third digit is not confirmed. So 3 dp, third digit is not confirmed. So I will do same process 1.47075 plus 3, and what I get x7. So let's see, is coming 1.47119. So if I check it now, I think I can say easily that this, look at the third digit. So this is a third digit is very, very important for us to understand. Okay, we need this one. So this number is 8, then 7, this 1. So it means this is a no more changing further. So answer is finally, we can say 1.471 because he's asked us for what? He asked the 3 dp. So it means this is our final answer. I hope so. The concept is very, very